Hi, this is Sung, and I'm the Principal and Director of Sky Academy. And in this episode, what we're going to be looking at, from here on in, what we're going to be looking is applications of sequences and series to the real world. Now, the most obvious application and the one that this course focuses on is its applications to financial maths, in particular, compound interest, annuities of superannuation, etc. But there are a whole lot of other applications in the real world as well, okay? We're going to be looking at applications that sequences and series of an arithmetic nature have in real life, okay? And in this episode, we've got one example that I want to go through, okay? So let's read this out together, all right? An employee is paid at an annual salary of $15,400. Each year, she receives an increase of $800. What is her salary in the 11th year? And what is her total earnings in the 11 years? This is clearly, and you need to be able to recognize this, this is clearly a arithmetic series, okay, or arithmetic sequence, okay? And the reason why it's arithmetic in nature is that you're increasing her salary each year by $800. And that $800 is an amount that doesn't change. It's a common difference. And when you increase by a common difference, it's arithmetic in nature, okay? So we're dealing with an arithmetic sequence at least in part A. Your beginning salary is $15,400, so it gives us a good starting point to attack this question, all right? So what I'm going to do is basically write out what we need to find. Okay, what is her salary in the 11th year? The 11th year would be the 11th term, okay? So what I would say is we need to find T11, okay? Now, we know Tn is equal to A plus, and we'll need to remember this formula, n minus 1 lots of D, yes? And over here, we'll work out what each of the values is. A is equal to 15,400, because that's the starting value. So she starts off with a salary of $15,400. So A is equal to 15,400. D, which is your common difference, will be $800. That's how much her salary is going to increase each year. And N is going to be 11 because we want to work out what her salary is in 11 years. All right. And what we need to find is T11. Does that make sense? Cool. Well, we've got everything we need to do the algebra for this question, or the arithmetic for this question. So what we've got to find is T11, which is basically $15,400 plus 11 minus 1 lots of 800. So basically what you've got, you substitute 15,400 for A, you substitute 11 for N, and you substitute 800 for D. And you end up with something like that, which ends up being 15,400 plus 11 minus 1 is 10. 10 times 800 is 8,000. So your answer will be $23,400. Therefore, salary in year 11 is $23,400. Got it? Let's have a look at part B, because what part B is looking for is your total earnings in the 11 years. Your total earnings will be the sum of all your salaries. And there'll be 11 salaries altogether. It will be the sum to 11. So we need S11. We're looking for S11, right? Now, what we know is that A equals to $15,400. We know that L, which is your last year's salary, or T11, will be the T11 that we just found, which is equal to 23,400. We know that N is equal to 11. And I think that's all we need, because the sum of an arithmetic series will be the number of years over 2 times your first plus your last value. That's an L, by the way, A plus L. Okay, so what we've got is 11 over 2 outside of 15,400 plus 23,400, like that. We need to put those numbers into our calculator. I've got a calculator right here with me, okay, and I'm going to work it out. And her total earnings over the 11 years, 213,400, okay? Therefore, total earnings in 11 years is $213,400, okay? So this is a typical sort of question that you might get in the 2-unit course early on in the paper. And what it does is it goes through, or it tests your knowledge of arithmetic series and your ability to apply an arithmetic series to a problem, to a word problem. So hopefully that will have helped you. On the next episode, we'll be launching into compound interests, annuities, etc. So I look forward to seeing you on the next episode. Thank you very much for watching.